Our next unit of review is exponent rules. So first of all, a reminder that exponential form is simply repeated multiplication. For example, 3 squared is simply 3 times 3. So some other additional vocab is when you're looking at a power, the base is the number that's being raised to an exponent. Reviewing our property rules, I'm going to go over these quickly. I know you've seen them before. And our essential question today, as you'll see on our next page, is why do these properties work? So I want you to think about that a little bit as we go through these, and we can talk about some of them in detail tomorrow in class. So our first rule is a power times a power. You add the exponents to simplify. Next, if you're dividing powers, you'll subtract the exponents. A negative power means you flip it. So if the negative power is in the denominator, you flip it to the numerator. Rule number 4, anything raised to the 0 power is 1. Rules 5 and 7 are similar. They're a variation of distributive property with powers. And rule number 6, power of a power, you multiply those exponents. I mentioned our essential questions, so we'll start taking a look at simplifying expressions. If you look at the right-hand column this time, I've got some steps for you to follow if you choose to use those to simplify your expressions. And looking at step 3, it is optional if you want to simplify negative powers first, because your final expression should have no negative exponents. So looking at example A, first rule is make sure that you treat your coefficients like coefficients and not like exponents. So I do see a lot of students start to confuse those two different rules once we start working with powers. So make sure you understand that this 3 is a number, not an exponent, as is this 4. So we will be multiplying those together. And then we have our powers. A times A gives us A squared. And B to the 4th times B to the negative 3, we will add those powers and get B to the 1st power. Our second example, we're simply using our power rules, so we're going to distribute this power to everything inside the parentheses. Again, treat that 2 like a regular number. 2 cubed is 8, x cubed, and then y squared cubed. We multiply those powers together and get 6. Part C, we have a rule that anything to the 0 power is 1, so we actually just have 3a times 1, or 3a. Part D, I'm going to start this one by simplifying the negative exponent first this time. So I'm going to keep my 5 in the numerator. It has no negative exponent. The x cubed moves to the denominator, and that power becomes positive, times y, and everything is squared. And then I'm going to distribute that square to everything inside the parentheses. So in our numerator, we have 5 squared, which is 25. In our denominator, x cubed squared is x to the 6th, and y squared. Final example for our power rules. Again, on this one, I'm going to simplify those negative exponents first. So in the numerator, 12 and a cubed still have positive exponents. The a to the negative 2 that is currently in the denominator, I'm going to flip it to the numerator and make that exponent positive. In the denominator, 4b have positive powers, and then this b to the negative 4 in the numerator will flip to the denominator, and the exponent will become positive. Next is, again, remember to treat your coefficients like regular numbers. This is a fraction that we are simplifying. 12 divided by 4 is 3. In the numerator, we're multiplying a cubed and a squared, so we'll add those exponents. And in the denominator, same thing, b times b to the 4th. We'll add those exponents as well.